So this is my problem number 1. Given the equation y double prime is equal to 1 over square root of 1 minus x squared with the condition y of 0 is equal to 1 and y prime of 0 is equal to 0. So we will get the general solution for this equation. And to solve for this solution, we will integrate both sides with respect to x. So we now have y prime is equal to integral of dx over square root of 1 minus x squared. So by calculus, in integrals yielding inverse trigonometric functions, y prime is just equal to sine inverse x plus cy. So we will consider this equation as equation 1, where our cy is an arbitrary constant. But since it is given in the condition that y prime of 0 is equal to 0, we can solve for the value of c1. So by substitution, 0 is just equal to sine inverse of 0 plus c1. So our c1 is just equal to 0. So going back to the equation 1, since c1 is already 0, we can solve now for y by integrating both sides again with respect to x. So we have y is equal to integral of sine inverse x dx plus c1, which is equal to 0. So we will use integration by parts to solve for the integral of sine inverse of x. So let u is equal to sine inverse of x, du is equal to 1 over square root of 1 minus x squared dx. Our dv is just equal to dx, so our v is equal to x. By substituting the dollar data into the form uv minus integral of v du, so y is equal to x sine inverse of x minus integral of x dx over square root of 1 minus x squared. And to get the solution for this given integral, we will let w is equal to 1 minus x squared. So our dw over 2 is equal to x dx. So again, by substitution, we have y is equal to x sine inverse of x minus negative 1/2 integral of w negative 1/2 dw. So by manipulation, this will give us a result of y is equal to x sine inverse of x plus the square root of 1 minus x squared plus c2. So we will consider this equation as equation 2, where our c2 here is an arbitrary constant. But again, since it is given in the condition that y of 0 is equal to 1, we can solve for the value of our c2 here. So by substitution again, y is equal to 1 and then is equal to 0 sine inverse 0 plus the square root of 1 minus 0 squared plus c2. So this is 0, this is 1. So our c2 here is equal to 0. So by plotting all the values we have, we already have our final answer. So this is our final answer. Y is equal to x sine inverse of x plus square root of 1 minus x squared plus c1 plus c2. Since our value for c1 and c2 is just equal to 0, then we can cancel these two terms. So we will end up with y is equal to x sine inverse of x plus square root of 1 minus x squared. So this is now the general solution for the given equation.